All right, let's do another one. Uh, so today we're working on the last problem for week 3, excluding the LeetCode premium question. So this is going to be number 33 of our grind 75 169 questions series, I guess we can call it now. So today we're going to be working on number 234 palindrome linked list. Given the head of a singly linked list, return true if it's a palindrome. Now, I've done this problem before, and I had to say that this is one of my favorite problems on LeetCode, or at least on the Grind 75 list. Mainly because I think it shows really the importance, I guess you could say, of knowing your fundamentals. And what I mean by that is that a solution to this problem, I won't say the solution because it may not be the only solution, as is the case with many of these algorithm problems. But a solution that can be used involves using the solutions of two prior LeetCode easy questions, and that is both using the two-pointer approach to find the middle of the linked list, and then reversing that singly linked list. So both of those sort of solutions are used. So the idea is that first, use two-pointer, specifically fast and slow, to find the middle of the linked list. Because in this case, we're trying to find if the linked list is a palindrome, and unfortunately, there's no way to index into the middle of it in a way that we could with something with a data structure that is continuous, such as an array. So this is one approach to actually find the middle of the linked list. Then once we find the middle of the linked list, we reverse the second half of the linked list. And this is so that for our third step, use two pointers for the third time. We can check each element and return false if they differ. Basically, once we take the linked list, basically, we split it up into half by reversing one side, and then we start at basically the ends of both of those linked list halves, and then we go slowly towards the middle until both of them are null, in which case we return true, because then it would be a palindrome. Otherwise, something would have ticked them off. So that's the solution that I remember using. I think this is a great solution, like I said, because it builds off of some of the fundamental concepts that you learned in earlier LeetCode questions, such as the finding the middle of the linked list, such as reversing the singly linked list. And it just ties it all together in this sort of beautiful way of a not quite as easy, but still easy sort of LeetCode problem in the form of palindromic linked list. So with that said, let's go ahead and start coding. So first we'll go ahead and find the middle of the linked list. And we can split this up into their own functions. So middle node of linked list. And this will return a list node. Maybe a nullable list node. Eval middle is equal to middle node of linked list with the head as the pointer. And we can, the number of nodes in this list is in the range of 1 to 10 to the 5, so we know that for, in any case, we will always have a node in our list. But we can say if head.next is equal to null, then return true, because if there's only one element in our linked list, then of course it's true. Technically, this should be a list node non-nullable type, because then this is gonna be a we'll just do that. This case will never, ever, ever fire. But that's something to appease the compiler, basically. So now we can pull in our old solution for our middle of the linked list. So we can do val or if head return null. We can say var slow is equal to head, var fast is equal to head, while slow or fast dot next is not null. Fast is not null, and fast next is not null. Because in this case, when we do the two-pointer approach for the fast pointer, if we have an even list like this, it'll jump up 2, and it'll jump up 2 again. So in that case, it'll be null. But if it was an odd number, say we had another at the end of the list, then it would end at the last node on the list. So we can say fast is equal to fast.next.next. Let's see, fast, we know that the next is not null, but we don't know that the next is not. Let's see, actually we know both of these are not null. We know that fast is not null. We know that fast next is not null. We just don't know if fast next is null, but that doesn't matter. Slow next, and then return slow. And we can just do some print line middle dot val just to verify that this is the case, and we'll just return true in this case. 1 2 2 1 2. So this should return, we'll make this distinct and we'll say 3, we'll say this is also 3. So we should see 3 repeated twice. Let's see. Slow is slow next. Right, okay. We'll do this and we'll toss in this. Though technically we do know that since fast will be faster than slow, then slow should never be null, but 3 and 3, cool. Okay, so that seems to point in the direction that our middle of the linked list is working. So we can say we can work on our second function, which is going to be our reverse linked list. And we can say for here, if head is equal to null, return null. Var slow is head, var fast is equal to head next. And in this case, our fast will not be traveling at the speed of so we have 2 edge cases in this case. If it's null, then we return null. If it's if there's only one element, then we just return the head. It doesn't matter. In this case, our fast pointer will just be one node faster, one node ahead of our slow pointer, rather than moving at twice the speed, as is the case of the middle node of linked list function. And we can say while fast is not null. This might need changing in a bit. I need to think about this some more. Var temp is equal to fast next, because we will lose our reference to that. We want our fast next to be equal to our slow. Then we want our slow to be equal to our fast, and our fast to be equal to our temp. So basically this, so for example, if we had an example like 1 2 3, this would reference 3, then this would switch from 1 to 2 to 2 to 1. Then this would go from 1 to 2. And this would go from 2 to 3. Then we just need to make sure that we don't run into a cycle here. Let's see. Slow.next is null. So this just manually sets the head next to null. No, but then we'll lose the reference to... Actually, will we? No, because we already stored the reference here. So yeah, so we just want the head next to be equal to null. And then, let's see. Fast, we know that fast will not be null. And then we just return slow at the end of this, which becomes the new head. Because at this point, fast will be null, which means that we've reached the end of the list. So val a second, or I guess we can say reversed head is equal to reverse linked list centered at the middle. And we'll print out the reversed head, which should be, we'll say 2 right there, put a 3 right there, so that we have confirmation that it indeed did loop over. Let's make this more clear what it's doing. And then let's see. This is still a little bit bothering me. Is this the case? Is this something that we should do? It's been a while since I've done reverse linked list. We do want to set this initial slow. We do want to set this initial slow to null, the next to null, after we have the pointer to the fast. Primarily because we don't want this to cycle. Because if we don't do that, then our fast next will be equal to slow, and then we create a cycle here, and we don't want that. If this gets set to slow, the next sets to slow, then then we move both of these pointers up. Then this next moves to slow, and this next is already there. Okay, yeah, so I think this actually does make sense. But while fast is not null. Yes, because when fast is null, then our slow should be the end of the list. Let's just make sure by running a reversed head. Okay, cool. So that does seem to have worked. And then we can say, while head is not null and reversed head is not null. So while both of these are not null, if head val is not equal to reversed head val, return false. Head is equal to head next. Reversed head is equal to reversed head next. And then now equal null, and reversed head is null. And we can wrap this around parentheses. Basically, we want to make sure that if one of them is null, then if one of them is null, then we then that automatically makes it not a palindrome, because then we have more characters on one side than the other. Though actually, now that I think about it, I wonder if we ever will hit this case because of the fact that we are splitting it in the middle each time, right? There's no way for a palindrome, or in this case, for it to be split unevenly. So technically, this case should never exist. So I'm going to cut down on the extra calculations and just say return true at that point then. So let's run our code now and let's see where we end up. Right, we need this to be reassignable. We'll call this regular head. So that it is assignable. Or, sorry, reassignable rather. Okay, let's run through all the test cases. Let's throw in a weird one. Let's throw in a single node. And let's see. I just am now noticing the follow-up asking to do it in linear time and constant space, which, funnily enough, this is the solution that does do that. So let's toss it into the submission and let's see if there's any issues that we run into. Surprisingly slow. I am not too sure why that is the case. Because this is, for all intents and purposes, this is linear. What we do is that we iterate through the list, or half of the list once, to find the middle. Then we iterate through half of the list, the other half of the list, in order to reverse it. And then we run through the halves individually, or well, at the same time, right? We run through the halves of the list a third time. So this is a linear solution, and it is constant space. The space seems much more reasonable, but I'm really not sure about that runtime. That runtime seems oddly slow. Like surprisingly slow, which I'm surprised about. Is there any case where we could have saved time here additionally, I guess? And this would be down to like individual, like smaller calculations that or smaller adjustments. Let's see. We have that. This can't be further optimized, I don't think. And that leaves these algorithms to be further optimized. We need both of these conditions because the fast next could either be null or the fast could be null. So I think this is as far as it can go realistically. Maybe there's something to do with the reverse linked list. But that's just two-pointer logic. Meh. I mean, in the grand scheme of in the grand scheme of uh, big O runtime, asymptotic runtime, I think this is a perfectly fine solution. It runs within the linear runtime parameters. It runs within the constant space parameters. Any further optimizations would be done, could be basically done by just writing this. Like if we were really pressed for performance, I think that this would be something that you would rewrite in like C++, right? But I am gunning for maybe Amazon. I'm not gunning for quant trading. That's just way too dank for me. So I think this is a perfectly fine solution. It runs within the parameters allotted. I'm fine with this. I'm perfectly fine with this. So I'm going to leave this here. So 28.37% runtime, 68.82% speed, space. And this is number 234 palindrome linked list done in linear time, constant space. And that actually rounds out our week 3. And next week, when we delve into week 4, we are going to start running into some LeetCode medium problems. And that is going to be a journey all on its own. And I'm looking forward to that. So the two that we have at the end of week 4, insert interval and O1 matrix, those are going to be interesting medium questions. And we'll see how far we can get with those. Or maybe we'll need to break it off into I was thinking that if these problems start to get way too intense, I might even consider streaming the ordeal rather than recording. But in any case, I hope you learned something. If you have any suggestions for improving on this time, feel free to let me know in the comments down below. But other than that, I hope you learned something, and I will see you for the next problem.